Preventing waste brightens our lives. Welcome to Kinetical Science, the why behind the what. I'm your host, Juan Manuel Garcia. Customer expectations must be met by product performance. Otherwise, we feel robbed when we do not get what we expected or paid for. What went wrong? We lost control. There are many sources of variation, and we frequently miss some of them. One aspect frequently forgotten when investigating an issue is the simultaneous interaction of multiple variables. Yes, it is complex, but in real life, interactions are simultaneously connected, affecting and being affected by others. Nature is a way, and we must consider this fact as well. Variation occurs at every point on the production chain, from initial sales negotiation to delivery of product or service. The potential for errors is inherent to them all. Also, variation accumulates from beginning of the process to the final product in every single stage. If we could visualize variation on a complex system using a timetable and colored squares for factors, something like this we would see. Rows contain readings of all parameters taken together at a single time. Columns show data at time 1, time 2, time 3, etc. One column per variable. In reality, each row represents a different product, but the variation allowance agreed to with the customer permits considering product from all rows to be the same. At the end of the process, physical modifications, reactions, and synergistic interactions already happen, leaving behind none or barely any trace of individual variation. At that point in time, all we see is a combined result of what took place. However, not seeing variation does not mean it's not there. Let us talk about the small but powerful disaster generators. Quite frequently, the normally undervalued small components cause problems. Removing or replacing them is not always possible without losing important product's characteristics. Reducing variation to levels undetectable to the overall process performance is the best choice. Testing laboratory practices, methods, and product specifications are not exempt from errors and deficiencies. They are more frequent than thought and can be very costly. Process and product specifications must reflect real-life situations, even if they do not look nice. If we hide reality, we are going to do the same with our needs for support and problems grow out of control. We can pretend being better, but ignoring an issue makes things worse. Ambient conditions must be monitored and controlled, as they affect shelf life of raw materials and finished goods. Throughout the year, heat, humidity, sun exposure, lift traffic, and their exhaust gases discolor products by surface oxidation. What is the best way to measure process and product quality? This slide shows a probabilistic normal distribution curve in ranges covered for 1, 2, and 3 times the standard deviation, or sigma, relative to the mean or average line. Upper specification limit is calculated by adding 3 times the standard deviation to the mean. For the lower specification limit, we deduct 3 times sigma from the mean. To calculate CPKs, we separately compare the upper and lower specification limit to the mean or average and divide the result by 3 times the standard deviation. CPK tells us how close we are to fall outside the specification limits and what is the variability within the whole data collection. As mentioned, process capability or CPK compares the actual process variation to the level agreed to with the customer on the specifications. A CPK value of at least 1.33 is generally accepted, but the trend is to increase it as improvements are done. If process capability is low, either the specifications are wrongly set or calculated, or the process requires a significant improvement. Changes are impossible to avoid, but can be minimized to a state in which damage is acceptable or goes unnoticed. Preventing quality losses requires close and sincere collaboration across all elements of the production chain. Alarms are no substitute for errors on prevention, planning, execution, and decision making. They should be our last resource. Prefer prevention over correction, as alarms do fail. In summary, all factors participating on a single operation act simultaneously. Variation is transferred through all subsequent processes and steps. Keep vigilant, as quality of product or service continually change. Work always on reducing variation. Nobody is more interested in your success than your customer. Your stability guarantees their stability and lower production cost. Do we want a meaningful and enjoyable life? Considering the whole manufacturing, distribution, and marketing chain, the damages to our economy and disposable income due to variation are staggering. Defects are more expensive to produce than good items, as they incur in all the normal production costs, plus those of making, dealing, and disposing of waste, and the high stress all people involved on this vicious circle go through. Sometimes we feel very tired to correct something wrong. But if we do not fix it, we will soon be even more tired, frustrated, and in bigger trouble. We could even hurt ourselves or our teammates. For all this, let us act proactively and preventatively on any problem. Thank you very much for your kind attention.